All right, pleasant evening, everybody. My apologies for being late. Obviously, for circumstances which you are all aware of, it is heavily, heavily raining in Mandeville. I could hardly get a taxi to get home, but I'm not miss out for competition, no? So we're here. Better late than never. All right, lovely. Let me see. We have 19 persons in attendance. All right. Any announcements that I have for you? I don't. Remember, guys, next week Wednesday is Ash Wednesday. Even though it's online, it is still a public holiday. So, it's a routine for MI not to keep classes on Ash Wednesday. Right? So, there's no class next week. So you see, we lose out on another hour and a half again, which we won't be able to make up. However, we have to just do what we have to do with the time that we have. I uploaded, for those who needed some assistance with the analysis of data, I've uploaded in the Google Classroom some step-by-step layout of how an analysis should be written. And I've also left some samples in there for you as well. Yeah, so I've left some samples in there for you as well. You can go over there and check it out and see if you can use it as a guide to help you. All right, that is how an analysis is supposed to be done. Right? Nothing too crazy. You can use that. Also, even though there's no class next week, Wednesday, still I don't want it to be a case so we don't get anything done. So I will have a worksheet that's prepared for you, right? You don't have to do it on that day. Remember, we have persons here that are Christian based, so I'm not saying that you have to do it on that day, but I'll leave something in there for you, to be done. All right. Yeah, we don't want us, don't do anything because it's a holiday. All right. So that. No more announcements. I don't have anything available for you. Right. Again, I still haven't got back my phone as yet. As soon as it is. By the way, is there someone in here by the name of Prashad? I saw an SBA down by my school for somebody by the name of Prashad. Oh yeah, class is keeping this Saturday, but the next Saturday I won't be here. Yeah, so class is keeping this Saturday. I remember there's no more online sessions. Okay? All right. No announcements. Let's get into it. All right. So, remind me, where were we last week?
We were at reflection, transformation.
Okay, reflection. Lovely. All right. So, we should be going to rotation today. All right. Did we complete all the reflections in the X, in the Y? Y equal X, Y equal negative X? Did we finish it?
I tried, sir, but the final one, I'm not sure if that's how it's supposed to look.
Hold on. Wait, did I give you a question to try?
Yes, we were supposed to do it. We did three of the planes. So we were supposed
Three
to
of them.
do,
Yeah, man. The tree is
yes.
fine. The tree is fine. The other one is more or less the same thing. But then I don't want to
Because
use.
the other one, you said we were supposed to turn the thing upside down and
Oh, all right. We're not gonna stop on that still, cause we have to move on. We don't want to spend the time. I'll catch up onto it on next time, right? But as long as we get the concept of how our reflection is done, we should be okay. We should be okay. We need the questions then to really understand it more. But as long as we have the theory, so tonight we are going to be looking at the concept of rotation. Okay, rotation. So rotation, transformation. All right, take some notes from me, guys. I'm going to be dictating some notes for you. All right, here we go. Write some notes for me, guys. Rotation is the movement. Rotation is the movement of an object onto its image. Rotation is the movement of an object onto its image. By means of turning, by means of turning through a specific angle, through a specific angle known as the angle, through a specific angle known as the angle of rotation, known as the angle of rotation.
Sir, you lost me somewhere, like something repeat or whatever. So can you
Okay,
just
rotation
take
is
it
the
over?
movement of an object onto its image through a specific angle known as the angle of rotation. Known as
Sir,
the
I'm not sure me I follow. Can you just one more, please? Thanks.
rotation is the movement of an object through a specific angle known
Okay,
as.
sir, hold it right there because I have something different. What I have is rotation is the movement of an angle onto its image by means of turning through a specific angle, known as the angle through. That's what I have. I feel
As a
like me
road.
I'm mixed up.
I think you leave out the word object. Read over what you have. The rotation is the movement of an object. You have that in the first sentence?
Yes, I have that. Rotation is the movement of an object onto its image by its turning through a specific angle, known as the angle. Then Miss Son like me, I go repeat through then I had to then that's when I said stop. So I don't know. If I have something different from you,
Sir writing it on the board. He's writing
right,
it on the board.
right, good.
All right.
There no say I can't type it, right?
I try find the notepad that I'm gonna try to, but can't find it. All right, so there we have it. Rotation is the movement of an object onto its image through a specific angle known as the angle of rotation. Got it? Got it now?
Yes, sir, thank you.
Lovely. All right, good. Full stop. There are 4 standard angles of rotation. There are 4 standard angles of rotation. There are 4 standard angles of rotation. We have a rotation through 90 degrees. We have a rotation through 180 degrees. And we have a rotation of or through 270 degrees. For the purpose of CXE, we're not going to go past these 3. All right, 90, 180, and 270. Full stop. When an object is rotated, when an object is rotated, when an object is rotated onto its image, when an object is rotated onto its image, it is rotated from a specific position. When an object is rotated onto its image, it is rotated from a specific position. Which is called, or that is called, I should say, that is called the center of rotation. That is called the center of rotation. All right, just repeating the information. When an object is rotated onto its image, it is rotated from a specific position. That is called the center of rotation. Full stop. So therefore, what I'm saying is, whatever angle it's rotated through, that's called the angle of rotation. And where it's being rotated from is called the center of rotation. So where it's rotated from is the center of rotation. What it's being rotated through is called the angle of rotation. Full stop. Subheading, rotation matrices. Or just put rotation matrix. Subheading, guys, rotation matrix. Subheading, rotation matrix. Full stop. All right, so subheading, rotation matrix. The rotation matrix, the rotation matrix, the rotation matrix is a 2x2 matrix. 2x2 is written like this. The rotation matrix is a 2x2 matrix. The rotation matrix is a 2x2 matrix. consisting of ones and zeros, consisting of ones and zeros. The rotation matrix is a 2 by 2 matrix consisting of ones and zeros written in the form A, B, C, D. The rotation matrix is a 2 by 2 matrix consisting of ones, O-N-E-S, and zeros, Z-E-R-O', written in the form, as on the screen, A, B, C, D. Which is what we use to rotate the object. Which is what we use to rotate the object. All right. All right, so that's enough information for now. Let's give you a little demo of what's going to be happening. All right, guys. So I'm going to grab, say, x-axis here. Sorry, a y-axis here. Oh, let's not lose this one. What I have here, guys, is a x and y axis. And so I'm going to just do a quick little demo. What's going to be happening here is that I'm going to give you a shape. A shape will be provided to you. Something like that. Not maybe that, but do something like that, right? And the object will be called, let's say, A, B, C. So what we're going to be doing for this class is we're going to be learning how to allow the object to move from here to here, or from here to here, or go around here in a circular form. So basically what we want to do is that we want to take this object here and what we want to do is take the object and we want to rotate it like this. So the object is going to be here and we want to take the object and we want to move it around in a circle like that. And we want to move it along the x and y axis. So that's the objective of tonight. We want to learn how to do that. So before we can do that, we're going to look at the rotation matrices first because it's the matrix that allows us to move it. So that was a demonstration, right? So after we rotate the object, it probably going to look something like so. Then they're going to rotate again, they're going to look something like so. Then they're going to rotate again and then look something like so. So we don't know exactly how it's going to look. We don't know exactly where it's going to land, but the matrices is going to help us to know what's going to happen to the object and the image. So let's look at the rotation matrices. Zoom user, I think your cursor is in my way.
Sorry, sir.
That's okay, dear. All right, so here we go. We're going to use this formula. Fortunately, sadly, it's not given to you. Sadly, a lot of people don't even know it. Sadly, a lot of people don't even teach it. Them just leave it up to chance. So it is cos theta minus sine theta, cos theta. And this allows us to rotate the object through the angle. So what do you mean by that? How can this help us to rotate an object? Now, from this formula, we're going to say where.
Mr. Peart,
Yes, there.
sorry to disturb you. I don't know what is happening, but I'm not seeing your board.
You have to exit the class and come back in.
I did that and it's the same thing come back up. It says I'm unable to load this whiteboard.
Okay, hold on. I see my instructor did this at NCU. Hold on. I see him do this at NCU. Hold on. All right, are you seeing a board now?
No.
All right, hold on. All right, tell me if you see my board shortly. Hold on. Seeing it now? Still not seeing it?
You're not seeing it.
Oh, I'm gonna know then. Because normally when I exit, all right, let me see if I can stop sharing the screen. And then I'll try again. All right, I'll try again. Can you see it now?
Sure.
Seeing it now? Nisha? Oh, she's probably gone. All right, guys. So we're theta. We're theta. That symbol you're seeing here. Hold on. So this symbol that you're seeing here, it's a trig function symbol. Where theta is called the angle of rotation. All right. Let me give you an example. So let's say that we had an object, right? Could be a point, could be a straight line, it could be a shape, a triangle, a quadrilateral, I don't know. It's just it's an object. So remember that an object is a point. It could be 2 points, which is a line. It could be 3 points connected, which is a triangle, or 4 points connected, which is a quadrilateral. And we want to rotate whatever this thing is, but we want to rotate it through, say, 90 degrees. So rotation through 90 degrees. All right. So watch the process now, guys. I'm going to replace all those red arrows that I have there. I'm going to replace each of those symbols with 90. Somebody can take out the calculator and help me, please, because I'm going to need some help. So I'm going to go ahead and I'm going to say cos 90 minus sine 90, sine 90, cosine 90. All right. Can someone go ahead and tell me what is the cosine of 90?
Sir, I'm seeing 0.
Correct. What is the sine of 90?
1.
And the minus that there makes it -1. What's the sine of 90 again, which is 1? And the cosine of 90 is 0. Do you see the zeros and the ones now? These are the zeros and the ones that we were talking about earlier, where we say that the rotation metric is a 2x2 matrix consisting of ones and zeros. So by you finding cos of the angle, sine of the angle, cos of the angle again, and sine of the angle, you end up with the ones and zeros. So how do we move from the ones and zeros now to know what happens under the rotation? So after moving to that section, we're going to go ahead and we're going to label these. This is X. This is Y. This is X here. And this is Y. Now, remember that when you're given a point, once you're given a point, every point is labeled XY. Every point that I give you, every original point I give you is XY. Now, something is going to happen to the point. It's going to be rotated. So once you rotate something, it's not going to be the same thing. Let us figure out what's going to happen. So, question. Let me grab a cursor. Question. How many X's right here? What number do you see under the first X? Under the first X, what number do you see?
0.
That means there's no X at the top. How many Y's are at the top here? Right here. Under the first Y, which number is there? 1. Thank you, Sashmonique. 1. So therefore, that means that for the top part, we're going to have Antonella, your cursor is in the way there. Thank you. So at the top, there is no X, but there's a Y at the top. And at the bottom, there's 1X.
Excuse me, sir.
Yes, go ahead.
Will the class be posted on your YouTube channel?
All my classes are posted on my YouTube.
Okay, because I'm having problem with the internet. The phone keep freezing.
Understood. All my classes are posted. Everything is posted.
Okay, sir.
So it will be available 7 o'clock tomorrow.
Okay, sir.
All right. All right, guys. So let's go back to this here. So here at the top, there is no X, but there's a Y. So we're going to have 1 Y at the top here. And at the bottom down here, there's 1X, but there's no Y. So if you take this blue thing down here, so observe and tell me what changes you saw occur. Can somebody tell me what happened? After the XY got rotated, it becomes negative YX. What do you think happened? Tell me what you see happen to the X and Y. What changed? What went up, down, what changed? This was the original point. After it got rotated, that's what it became. Observe and tell me what changes you saw occur.
Go upside down.
So the points were inverted, and what else happened?
The Y became
End up
negative.
being negative.
Well, in this case, the Y become negative, but we don't usually say that. We usually say that the sign changes. So for this here, under rotation through 90 degrees, we can see that the points, we didn't see the points. Under rotation through 90, we can see that the coordinates got inverted. So the coordinates got inverted. And the Y value changed. And the Y value changed. So the coordinates got interchanged or got inverted. So you can see that the Y went up and the X went down. And the Y changed from what it was to something else. It changed to the opposite sign. So therefore, you can see there that That's what happens under a rotation through 90 degrees. Now, we so see it graphically. Just give me a few moments, right? We just want to write them out first. So under rotation through 90 degrees, we can confirm based on the calculation that whenever an object gets rotated through 90 degrees, the points will be inverted and the y value is going to change. It's going to make sense shortly. Just give it some time. I'm just going to get the notes out of the way. Let's look at a rotation through 180 degrees. So once again, I'm going to take the formula, which was given to you earlier. Cos theta minus sine theta cos theta. And in this case, what we're going to do is instead of putting 19 there, we're going to put 180. So I'm going to go ahead, I'm going to take out these theta, I'm going to put 180 there. So I'm going to have 180, 180, 180, and 180. All right, go ahead, guys, and can someone tell me what did you get when you find cos 180 on the calculator?
-1.
All right, what is the sine of 180?
Zero.
And there's no such thing as minus 0, so we just put 0. Sine of 180 is 0 again, and the cosine of 180 is -1. So this now, that -10, notice that it looks different from the first one up here. It's a slight little difference. So what you're going to be getting, this formula is going to always spit out what is called the rotation metric. So I'm going to go here, and at the top, we're going to have x, y, x, y. Now, tell me how many x at the top? Minus x. No y's at the top. At the bottom, there is no x, but there's a negative y. So notice that there's a slightly different change that occurred. If I had a point, xy, and if I rotated it through 180, I'm going to end up with minus x minus y. Can you tell me what changes you observe occurred?
Both the signs changed.
Pardon me?
Both the signs changed.
Very good. Excellent. I love what you said too. You didn't just say negative, you said change. And that's what is important. Because if the points are negative, it's going to become positive. And if they're positive, it's going to become negative. So in this case now, we're just going to say that the signs of the coordinates change. So for this one now, we're going to say that the signs of the coordinates change. So the signs, only the signs change. All right? So that is what happens
sir.
through, that's what happens through 180 degrees.
Senior board now, sir.
Wonderful, great. Oh Lord. As soon as I said that, so the board disappear. Can you believe it?
This is serious.
Better pray say come back. Oh, you come back. All right, here we go. Now, let's do the process again now, but this time we're going to do it through 270 degrees. Anybody needs a screenshot? Anybody needs a screenshot?
Yes, sir. Hold on 1 minute.
There it is. I'm giving you a chance to get a screenshot.
Thank you.
Sir,
Welcome.
too many persons have stuff on there making it hard to take.
Yeah. Renardo, Hansen, your cursor. Right, there it is now, Miss Gentles. Good to go?
Yes, sir. Thank you.
Lovely. All right. Now let's move on to the 270. So repeat the process again. For 270, rotation. Why am I spelling rotation wrong? Rotation through 270 degrees. All right. So grab the formula again. Cosine 270 minus sine 270 sine 270 cosine 270. All right. Need some help? What is the cosine of 270?
0.
All right. Now, careful with this one. What is the sine of 270? In fact, you know what? Type it in the calculator. What is minus sine 270? Let's not stress you out. Just type what is minus 270, minus sine 270.
1.
1.
What is the sine of 270? Just the sign. Leave out the minus for this one right here.
-1.
Very good. And what is the cosine of 270? 0. So there you can see we have another set of ones and zeros, but they slightly look different. Let me show you. If you look at this one down here, look at all of them. They have a slightly covariances. Now, your job is not to study them, because you will go mad. I never study these. I don't have them in my head. So I just make sure that I know the formula, and then the formula tells me what it is. Because I don't have time to study the combination or the order of it, right? So I just have the formula in my head, and then I just punch the numbers in, and it tells me what the metric is. Now, just like before, x, y, x, y. At the top, you don't have any x, but there is a y. And at the bottom, you have a negative x, but you don't have any y. Do you see that xy, which is the original point, undergoes a, Natalia? Cursor is in the way, love. Thank you. So xy send the arrow, and then it become y negative x. Now, can you tell me what changes you observe occurred? What happened?
Sir, they both are inverted and the x value sign changed.
Very good. Excellent job. So the coordinates got inverted just like the first one. So the coordinates got inverted. And the coordinates, and the sign of the x changes. And the sign of the x changes. Now, please bear in mind, but I will study that. The only thing you need to know from this class, when this class finish, the most important thing to learn, let me grab a different color ink and highlight it, is this thing here. Make sure you know the cos form. So the cos minus sine, cos. Once you know that, you know everything else. That contains all that you need. Because once you know the formula, you just punch in the angle that you're rotating it through, it's going to spit out the ones and zeros automatically. And you just label them x and y, and then write down the changes that have occurred. All right? So what you've just discussed there is how to derive the rotation metric. CSEC loves to ask you for the rotation metric. They love to ask you that. All right? So that is the end of that section. Now, let's put this to practice. We need to put it on the graph so you can see. Too much writing. Look at all of this. Too much writing. See that? It's very confusing when you look at it. It's just a bunch of writing. We now have a graph to see what it looks like. So let's put a graph to it then. All right? So hopefully you guys have a graph. If you don't, you might have to follow my screen. And I have a video on this already, so I think Miss Gentles, was it a playlist that I sent you? Or was it a specific video?
It was a playlist.
That contains everything, right? So I'm assuming that you sent it in the group, right?
I think that was sent in the group from
the last week.
Yes.
Yeah, man. So just check the last playlist that you sent in there. It contains all my transformation videos. So this is just a live version you're getting. All right, so let's put on an axis. Now, in the meantime, in between time, if you have a graph, go ahead and plot these points for me, please. Let me see. Sorry, I'm doing a sketch beside myself. Hold on, give me a sec, guys. I want a nice one to rotate, but I want it to have varying points as well. All right, so let me see. So 3. All right, let's try that one. And let's do okay. I'm trying to get us some points, guys. Give me a sec. Another 3. Take 1. All right. So go ahead, guys, and plot these points for me. If you have a graph, you can follow. If you don't, just await my. Let me draw it on the screen for you. So A. Sorry, guys, I'm so sick. Why is it looking like this? Okay. All right, so A, open bracket, -2, 3. B, 1, 6. And C is 3, -1. All right, so if you have a graph, go ahead and plot those for me. And then use your ruler to connect them. If you don't have a graph with you, which you should, but if you don't, just await me to draw it on the screen for you. All right. So go ahead and do that for more. All right, here we go.
Sir, I'm not seeing the number.
Not seeing it?
Yeah, I'm seeing it now.
All right, so I've just constructed my X and Y axis. All right, so I'm going to plot my points and tell me if you have a shape like that or close to that or you envision a point like that. So my first point is -2 to the left and 3 up. So I should be somewhere here. -1, -2, minus. So that's 1, 2, 3. I should be somewhere right here. Right there, so. Then the next one is 1, 6. So that's 1 to my right and 6 up. So this is already 3, 4, 5, 6. So that's 1, 6. I should be right here. And then I have 3, -1. So that's 1. This is 2. This is 3. -1 is down here. So that's right here. So I'm going to use a ruler now and connect these dots. That's 1 here. Shape here. Oh, whoops. That's 2 there. And that's 3 here. So you should end up with a shape looking like that. All right, I'm going to label them. This is going to be point A. That is point B. And this is point C. So this is the shape that I'm intending to rotate. For every rotation that I do, I'm going to draw them in a different color so you can distinguish between the rotation. All right, I'm going to put a little key up here. Every time I do a rotation, I'm going to put a little key so you remember which one is which one. All right. Now, shortcut time. Okay. Now, let's go back to, because I don't want to do this all over again, right? Let's go back to rotation through 90. After we went through that process of cos 90, minus sine 90, sine 90, and cosine 90, based on our calculation, we observed that every point will have this sort of effect. So every point will have this sort of effect right here. Negative y, x, right? Remember we just did that? So if we rotate an object through 90 degrees counterclockwise, every point that we have is going to be inverted and the sign of the y is going to change. So if I go back over here, remember it's negative yx. If I go back over here, and let me just grab these points again. Sorry. Let me just grab these points again. I need to learn how my teacher do this, you know. Him have a look away where him like him grab the whole thing and copy it, like him duplicate it. That is crazy. Like him do a nice job. I don't know how him do it, you know. Remember we when like him duplicate it or something. And to ask him what him do. Or I need to watch it on YouTube or something. It's like a way where him grab it, like him grab the whole entire thing and duplicate. And he moves so fast. Anyways, so learn it. So zoom out here. All right, so I'm gonna grab the original points. -2, 3, 1, 6. And I'm gonna grab, hold on, let me write it over somewhere. I need some space. So I'm gonna grab the original points, -2, 3, 1, 6, and 3, -1. And I'm gonna rotate this through 90 degrees. So remember we said that through 90 degrees, the change that will occur is this. All the points are going to flip or invert, and the sign of the y is going to change. So pay very close attention to what's happening now. Remember, the points are going to be inverted, and the one at the bottom is going, the one will go up or go change. So look now, look carefully. All the ones at the top, right, are going to go to the bottom. So -2 goes down, 1 goes down, 3 goes down. But the ones going up are going to change. So when 3 go up, it's going to become -3. When 6 go up, it's going to be -6. And when -1 go up, it's going to become +1. That's why I said it doesn't change to negative. It changes. So this is when it goes through a 90-degree rotation. And we know this because of this thing that we did right here from earlier on. We run it through the metric formula. So notice that the number going up, remember say it was what? Could we go across here, so? Oh, sorry. So we go across here, so? Notice that we said that every point, let's zoom up here, right here. So look at that blue section there. So notice that we said that what? X go down, Y come up. But when the X go down, it remain the same way. But when the Y go up, it change. So that's what we're doing over here. When you come over here, so we are saying that all the numbers at the top, right here, all the numbers at the top right here will go to the bottom. So that's why we have the -2 goes down here, the 1 goes down here, the 3 goes down here, right? And then now all the numbers at the bottom that went up, notice that the 3 became negative, the 6 became negative, the -1 became positive. All right, so that's what is happening. So we're going to go ahead now and plot these as if they were new points. Replot them and as if they were new points. Let's zoom out a little bit. Go over here. I'm going to plot these points now. Now I'm going to use the color. Let me see which color I want to use. Let me see which color. I'm going to use the color green for this one. All right, so this one is green. So let's plot -3, -2, -3, -2. So -3 to the left, which is going to be, let me just zoom up some more. Hold on. Come over here. So -3. So -3, -2. So -3, let me see. This is -1, -2, -3, -3, -2. So we're going to go down here. All right, so this is going to be -2 down here. So -3 is going to be right here. So -3 to the left and 2 down. I should land somewhere right here. That's the first point. I'm going to call that A prime. Haley, your hands are in the way. Haley, thank you. So -3 to my left and -2 come down. Then I'm going to go -6 to my left. So -3, this is -4 right here. This is -5. And this is -6. All right. So -6 to my left, and then we're going to go 1 up. So I should be right here. All right. So that's going to be my B prime. B prime. And then now the last one is going to be 1, 3. So 1 to my right and 3 up. So I should be up here. I'm going to use the green now to connect them. And you're going to see the rotation occurring. Oops. I used the one there. I'm going to connect this here. Connect that to that. Connect this to this. And then I'm going to connect that to that. So that now shows you the rotation of the black triangle. So you can see that. I'm going to put some marking so you can see what I'm going. So you can see here, what happened is that B got rotated so, A got rotated so, and C got rotated so. So it's turning, right? It's not very obvious because it's inside each other, but there's a turning effect taking place. All right, so that's for the green one. So the object got turned 90 degrees counterclockwise in the clockwise direction. Okay. All right. So I think you're gonna have a better time watching the more structured video on YouTube, because this one is live, so I'm using up a lot of stuff on the screen. But when you're watching one on YouTube, on my page, you'll find you probably will find it more interesting than this one. This one is kind of just very live, and you can see the mistakes that I'm making and stuff. But the one on YouTube is very clear. There's no error on that one. All right. Well, at least I don't think so. I don't remember. It was about a year ago that I did it. All right. So let's go ahead now and do the one for 180. We have 70 minutes, guys. So let me put this in green here. So you know, so this green one here is the one for 90. All right, the one that is colored, that is circled in green, that calculation there is for. All right, so let's write the points. What happened to the points now? So we're gonna say that for this one here, we know that xy became negative yx. That's for that one in green. In green. Now let's coach back over here and look for the one for. Let's coach back over here and look for the one for 180. The one for 180 said what? The points are going to just, well, not the points, the sides are going to change. So if I grab at the points that I have in red, let's grab at those points. If I grab at the points that I have in red, let's rewrite them here. I'm going to have -2, 3, 1, 6, and 3, -1. When I send it through a degree of 180 degrees, what's going to happen now is that all the signs are going to change. Nothing is going to get inverted. Just the signs are going to change. So what is negative becomes positive. What is positive becomes negative. I'm going to choose the color. Let me see here. I'm going to choose the color. There's not much color options here for me, but I'm going to choose the color blue. All right. So here we go. Choose the color blue. So -2 is going to become 2. 3 is going to become -3. 1 is going to become -1. 6 is going to become -6. 3 is going to become -3. And -1 is going to become 1. So basically what we're saying is that xy became -x, -y. All right. If we plot those, you'll see what we're talking about. You're going to rotate it 180 degrees. So this triangle is going to be in blue. All right. That means we can zoom out a bit. All right. Let me see if I can plot it now. So 2 minus 3. So 2 to my right and 3 down. So 3 down is going to be down here. See, 1, 2, 3. Uh-oh. Don't do that, Mr. Pierre. Don't move it. Go back. Back. Okay, here we go. So 1, 2, 3. That's 3 down here. That's 3. So 2 to my right and 3 down. So I should be about here. I think so. That's fine. Right there. And then I'm going to go -1, -6. So -1 to my left and 6 down. So that's going to be, so this is 3. This is 4. This is 5. That is 6. So -1, 6. I should be about here. So this is going to be my A double prime. This is my B double prime. All right. And then I'm going to have -3 up 1. So -3 to my left. 1, 2, 3 up 1. So I should be right here. And that's going to be my C double prime. Now, don't make it confusing because remember, only one you're getting. I'm going to get all 3. It just so happens that I'm using one graph to do everything. So I'm going to use my ruler now. I'm going to connect them. Here we go. This to this. This to this. And this to this. And you can see that once again, the black one got turned. It almost got flip over. Let's zoom it out a little bit so you can see what's going on. There you go. So it's turning. So you can see, look at this now. Look at B. Just watch the arrows that I'm going to draw. Notice that B, it went through here, then it went down here. Do you see the circle creating? Then A went to here, and then went to here. So that circle top forming. And then C now. C, hold on, we see there now. With the black on the C. So C went to here, and then went to here. So we don't want to confuse them. We take off those. So it's basically moving in a circle. It doesn't look like that's what is happening because it's 2-dimensional. You're looking at it from, but if it's 3-dimensional, you see the turning effect taking place. All right, and then we have the last one now. Remember that we are doing it on one graph, but remember when you get it on exam, only one single one you'll get. Okay, all right, so let's go back. Let's scooch back over here and see if we can observe what happens through 180. Sorry, through 270. See down here, so through 270 now, we're gonna grab all of this. Oh Lord, my Lord. I'd want to know how my teacher do this. I don't know how he does it. I think like him draw something around it and then him lift it up. I really need to study these things. My Lord. I don't know what he does. Him draw something around it and then him grab it. It's crazy. How does he do this? I don't know. He does something though. He does something. Anyways, not stressing myself. So for the 270, as you can see here for the 270, notice the change that occurred. Y negative X. Let's grab that. So we're going to scoot Y negative X. Let's scooch it back over here. Use our calculation. Oh, let me just put this back in blue. So you realize that this one is for the blue one. Right there. And then we already have the changes that occur right here for you. So you can see it. Okay. All right. So let's go over here then. Get some space. So we know that for this one now, for a rotation.
Let me just... Sir, can you just go back a little bit for me, please? Then we can get...
Sure, give me a sec. I'm gonna put this one in brown now, guys. Brown. All right. That fine? Can you see it?
Some other persons are on it.
Oh, Tony Ann. Tony Ann. All right, thank you.
Yes, I got it. Yeah.
Thank you. Okay. So this one's gonna be in brown now. Okay, gonna be in brown. So for a rotation, I don't want to put it in the way now. So for a rotation now, through 270 degrees. Remember now we said that every point is given as xy, and according to what we have over here, scroll over here, look at it, there it is, it becomes y negative x. We went through that process already. So y negative x. So that means that every point is going to be inverted again, but this time it's the x that's going to change. So let's go ahead and do some changes now. All right, so the original points were what? -2, 3. Let's put it at the top here. So the original points were what? -2, 3. And then we had 1, 6. And then we had 3, -1. So now when it goes through a rotation of 270, according to what we have here, remember we say xy, is going to become what? Y negative x. Then let's flip them and change the x. So the one going down is the, so let's look at it now. So the one going up is not affected. So this 3 goes up, this 6 goes up, this -1 goes up, doesn't get affected. But the one coming down changes. So -2 come down and became +2. 1 came down, became -1. And 3 came down and become -3. All right. So we're going to plot these now as if they're normal points. Plot them regularly like x and y. All right, so let's plot them. Let's see where we land up. 3, 2. So that's 3 to my right and 2 up. 3 to my right and 2 up. I think I should be about here. 3 to my right and 2 up. 6 to my right and 1 down. 6 to my right. So that's 3. This is 4. This is 5. This is 6. And 1 down. So 6 to my right and 1 down. I should be about here. And then the last one is -1, -3. So -1 to my left and 3 down. So -1 to my left and 1, 2, 3. So I should be about here. There. And so this is going to be A triple prime, B triple prime, and C triple prime. I use 3 different colors so you can distinguish between the shape. If I had all black, confuse the hell out of you. So now I'm going to grab here, grab the lines, change the color. Here we go. Here to here. Here to here. And here to here. Here we go. And there is our brown shape. Rotated. So you can see basically they are overlapping each other because they are being rotated around the center. You can see like a little diamond is being created right here. This is where it's been rotated from, right in the center here. So the objects are turning. I'm not sure if you had that kind of visualization, but the object is turning around the center. So everything is going around in a circle. Watch this. I'm gonna use that like a little curve and show you what's going on. Look at this. So look at me. B moves around in a circle, believe it or not. I'm not gonna be perfect, but I'm gonna try. So look at B. So the first B that we have, right? The first, let me use a different color here. What can I use? Let's use pale blue. Right? Look at this. B now comes like this. Watch. No, a circle. It's not in a perfect, but you get the idea. So B, basically, even if you have a graph paper right now, you could put your compass, the one that you put the pencil in, the one with the 1 point and 1 pencil, put the pointed part in the center right here and extend your compass to B and just spin it around and it goes through all the B's. It's gonna look amazing if you do it. Right? Just spin it and go right around through all the B's. You try with the A's, try with the C's, it makes a perfect circle. So when we talk about rotation, this is what we're referring to. The object is moving from its original position to a new position through an angle. And so from black to green is 90, from black to blue is 180, and from black to brown is 270, all of which are anti-clockwise movement. All right, so for the last thing for tonight, we have 3 minutes left. Let's go. I'm going to give you what are called properties. How do we recognize that a rotation is occurring? Not sure if anybody wants a full screenshot. There you have it. Take it now. If you want me to zoom it up a little bit, you can get it. Let me zoom it up a little bit. Here you go. Hold on, a little bit more. Too much. Okay, there you have it. So that's the best I can do. So that would be the notes for tonight. So when it comes to rotation, here are some key things you need to pay attention to. One, so the title is Properties of a Rotation. All right, so one, object and image remains congruent. Object and image remains congruent. Object and image remains congruent. Does anybody remember what did I tell you congruency means? Anybody recalls? No? Write it down. Congruency means equality in all respects. Congruency, CONGRUENCY. Congruency remains congruency means equality in all respect. So for the first thing is that congruency remains intact. All right. Number two, the orientation of the object will change. And in this context, the word orientation means order. The word orientation means order.
Repeat, sir.
Pardon me? Repeat. Number two, orientation will change. I think that's something like that, I say. I think so. The orientation will change. And the word orientation in this context means order. How the object looked at the beginning will change. There's a slight turning effect on it. Okay? But guys, this is just the theory. Like I said, this is just a theory. All I've done here is that I've shown you the tools and I've shown you what it looks like. This doesn't mean that you understand it, right? Because applying it to a question is a little different. So all I've done tonight was that I've just exposed you to what rotation is and how it looks and some key little things to look out for. But applying it to a question is a little tricky. So that's something that we're going to have to do in our spare time. Remember that I'll be here on Saturday at 1 o'clock for this Saturday. And no more online classes, please. So if you want to show up, you can. If not, you know the thing go. All right. With that said, please, guys, stay safe. Do not get sick like I have gotten sick. And I'll see you guys next week. Some of you on Saturday, some of you I'll see next week. Until then, have a good night.
Bye, sir.
Bye, sir.
Sir, I have a question.
Yeah, go ahead.
Sir, is this Saturday class has to be paid for like the Sunday class, sir?
Yeah. 500, same thing.
Okay, thank you. Good night.
All right, have a good night. Good night, everyone.
Good night, sir.
Good night, everyone.